right, so let's dive in here and let's look at the domain and range of these graphs. And we're using our friends over here at Desmos to help us graph these functions. And again, what we're asking is, what's the domain and range given some graph? All right, so we're going to use these graphs to help you out. All right, because I know a lot of you guys have questions on this. So when we're thinking about the domain, what I want to remind you of is we're thinking about the x values. How far left does the graph go and how far to the right does the graph go? All right, so keep that in mind. All right, so how far to the left is this graph going? Well, if I were to continue to trace this, it would actually go on forever to the left. So our domain, we start off with how far to the left is it going? Well, it's headed towards negative infinity. We want to use these parentheses because we know we're never going to get there. And likewise, how far to the right is the graph going? Well, if I were to follow it all the way to the right, it would go on towards positive infinity, right? Because it never stops moving to the right. So it's going to move towards positive infinity. And of course, it's never going to get there. So we have our open parentheses, right? We don't care what Buzz says, to infinity and beyond. No, we're never going to get there, right? So let's go ahead and there's our domain. And again, we're looking from left to right, just to help us out in terms of how we're thinking. And again, we also want to keep in mind, do we have any gaps? In this case, we don't. In a few minutes, you are going to see some, so don't go away. All right, the range. So remember, our range is how low to how high, right? So how low does our graph going? Well, we see it's diving down here, and it's going to go down forever. So it's going to approach negative infinity, right? It's never going to reach it. So once again, I'm using the parentheses here. How high are we going? Well, we're going to positive infinity. So we go to positive infinity here. And there's our range. So in this case, they're the same. Are they always the same? Absolutely not. So please do not get that confused. All right, so far there's our easy example. Let's add a little spice to this. All right, follow me. So now we're gonna look at this next function, this next graph of x squared minus 2. All right, so x squared minus 2. And I like graphing these, and I like looking at graphs so I really understand this idea of domain and range, right? So graphing is a huge tool, so make sure you know how to graph these functions. And if you're interested, let us know that you want to see these, and we'll make a video for you. All right, so the domain, how far to the left and how far to the right is this graph going? Well, we see again, it's going off to negative infinity. So to the left, it's going to negative infinity. And to the right, we see the graph is going off to positive infinity, right? To the right. So it goes off to positive infinity. All right, the range, once again, how low to how high. So how low is our graph, does it reach? Well, it reaches negative 2, and notice it touches negative 2 and it bounces back up. And because it actually does reach negative 2, we want to use those brackets to make sure negative 2 is included. So make sure you include negative 2. All right. Don't leave negative 2 out, or else it's going to feel a little bit like this guy. All right. And how high is our graph going? Well, we can see on both sides here, it doesn't matter, pick one, it's going off to positive infinity. So it goes all the way to positive infinity. And there's our range. All right, any questions? Perfect. Follow me to the next example. All right, so let's go ahead and let's look at this graph right here of 5 divided by x minus 3. So again, we're going to use our tools. We're going to use Desmos here to graph this, and what we're going to see is that our graph, and I exaggerated this blue line here just to illustrate and to let you guys know that our function, our graph here, is never going to cross this blue line, right? So it's never going to touch the line x equals 3. All right, it's going to get very close, infinitely close, right? Closer than you can imagine, but it's never going to touch that line of x equals 3. All right, so how do we talk about the domain here when we see graphs that look like this? Well, same idea, right? We look to see where is the graph headed in the x direction, right? So we go to the left. How far to the left is it going? Well, it's going all the way again to negative infinity. So it goes all the way in the direction towards negative infinity. But how far to the right does it go? Well, we see it goes to positive infinity, but remember what we stated earlier. Are there any gaps? Well, there are, because look at what's happening with this graph. It goes from negative infinity, and as I move to the right, this part of the graph is getting closer and closer to 3 right here. But we said it never touches. So it gets really close to 3, right? So it approaches 3, but it never touches. All right, but then we see the graph starts up. Here you can't really see. If I were to zoom in, you're going to see that the graph starts really close again to on the right side of 3, right? So again, if I were to graph this, you would see, if I were to zoom in, you would see the graph starts close on the right side of 3, and then it continues to move towards positive infinity. So because we have a gap right there at 3, I should say, right? We have all this empty space where the graph never touches at x equals 3. What we need to do is we need to communicate to our readers that we have a gap right there, right? Our graph is not defined at 3. There's no part of the graph located at x equals 3. So what we do is we write this U for our union, right? That tells us we have a missing piece here, right? But we just said our graph starts again, it starts back up again at 3, and then it goes all the way to positive infinity, because again, we're looking at the x direction, which is left and right. So it goes all the way to positive infinity there. All right, so now for our range. Remember, our range is how low to how high. Well, one other thing to note is that these graphs, they're going to get really close to 0 from the positive direction, right, from the top, and it's going to get really close to 0 from the bottom, from that negative direction, but it never actually touches. So for our range, how low is our graph going? Well, it's going all the way down to negative infinity. So it goes from negative infinity, and it's going up, and it's getting really close to 0, but we said it doesn't touch. So because it doesn't touch, we have our open parentheses, but then we have this gap, right? Because at 0, at y equals 0, right, this line right here, our x-axis, it never touches. But where does it start back up? Well, it starts back up very close to 0, and then it goes all the way to positive infinity. But to let our audience know that there is a gap, there is a place, right? There is a y value that's not accounted for. We have a little break right there, and then we start back up at 0. We don't touch it, so that's why it's a parentheses. And then we go all the way to positive infinity right there. So again, that's how we're going to take care of business whenever we have these gaps. All right, so let's take a look at another case. I'm not going to use decimals to graph this, but what happens if we just have a bunch of points? So let's take a look at that example. Follow me. All right, so when we're looking at the domain and range, we get this question all the time in Dr. Math Studios, so we want to make sure to address it. What happens when we just have points, right? Because this is where a lot of the confusion comes into. Well, because we have points, remember for the domain, we're listing what are all the x values that we're looking at here. Well, in this case, because I could actually list them, I'm going to use a set notation. In all those other examples, there's no way I could have listed every single point on those graphs. So I needed interval notation. But here, notice, I only have 1, 2, 3, 4 points. And because I could list them, I'm going to use set notation here. So I start with my smallest x value, which is this one. Negative 1, 2, 3. It has an x value of negative 4, right? Because this is the point negative 4, comma 1. So I grab its x value. And again, because I'm listing them, I'm just going to list them. Our next point is the point negative 2, negative 2. Oops. Negative 2. And so I grab its x value, which is negative 2, and I list it. And then I go to my next x value, or my next point, I should say, which is 0, 3, and I grab its x value, which is 0. And then I go to my last point over here, which is a 0.30. And I grab its x value, which is 3. So whenever they give you points, right, we could actually list our x values for the domain. All right. Same thing goes for the range. And remember, the range is how low to how high. But for the range, we're grabbing the y values. So we start with the lowest y value. And so remember, we're looking at the y values here. And so the lowest, the smallest y value is -2. Then we go with the next lowest y value, which is 0. Then we go with the next lowest y value, which is 1. Then we go with the next lowest y value, which is 3. And now that we've taken all those into consideration, into account, boom, you're all done. All right, folks. So again, when we're looking at the domain, we're trying to look at the x values. When we're looking at the range, we're looking at the y values, how low to how high. So if you found this video helpful, please do us a favor, smash that like button, subscribe, and we'll see you mathletes in our next video. Peace.